Alright, you guys, if you could please turn to Unit 5, Exponential and Logarithmic Functions. This video is going to be a little unusual because I actually recorded these parts, and I recorded it filling out each line piece by piece, and then for some reason the program lost the video, so I had to start over, but I didn't really want to rewrite everything, so everything's all written down. I'm just going to go through and explain it. Composite functions. Hopefully you guys are already familiar with composite functions. Basically, a composite function, f of g, is when you take a function g and you plug it in for x in function f. You basically stick one function inside another function. Okay? A one-to-one function is a function that associates each element of y with exactly one element of x. Okay, so whereas before you could have two x's with the same y value, a one-to-one function can't. So you've got exactly one x for each y. The horizontal line test is a lot like the vertical line test, except this one tests whether or not a function is one-to-one. So it's pretty much the same thing. You draw horizontal lines. As long as every horizontal line you draw only hits the graph of the function once, the function is one-to-one. If you can draw a horizontal line that intersects the graph of the function more than once, then it is not one-to-one. Alright, inverse functions. The graph of a function f and its inverse, inverse of f, are symmetric with respect to the line y equals x. If you want to find the equation of an inverse function, algebraically, what you want to do is you want to first switch x and y, then solve for y, and then at the end replace y with inverse of f. If you're looking for the graph of an inverse function, sometimes you can just eye it. You guys should all know what the line, where's my cursor? There it is. What the line y equals x looks like. Sometimes you can just reflect it over that line and draw it over here. But it does help if you are given some points. It does help to switch the x and y coordinates of the points that you're given. Kind of like if you have the point 1, 2, the inverse graph would have the point 2, 1. If you have the point negative 1, 0, the inverse graph would have the point 0, negative 1. And then at the end, you can just check to make sure that the new graph is a reflection with respect to the line y equals x. Alright, these next rules, exponential functions are, this is the standard form for an exponential function. Logs, the number e, natural log, I'm kind of hoping you guys remember this stuff from Algebra 2. We will be doing problems in class involving these. Alright, over here I've written down some of the basic laws of exponents and laws of logarithms. Once again, I'm hoping that you guys remember this stuff from algebra. I have also, however, written down the proofs for each of these three properties of logarithms, because I'm hoping that you guys can see the connection between the laws of exponents and the laws of logs. Where did my cursor go? There it is, in the laws of logs. Suppose that a equals log base a of m and b equals log base a of n. The basic property, the very first property we learned about logarithms, if you use that, that means that a to the capital A power equals m, a to the capital B power equals n. So log base a of m times n equals log base a, and I can substitute these two for m and n here. The laws of exponents state that you can just add a and b together. And the laws of logs state that you can cancel out log base a and a here, which leaves you with a plus b, which equals what we started with. Log base a of m plus log base a of n. This proof is very, very similar, except you're dividing, so you end up subtracting. This one over here, you end up using, you know what? I should probably write down this law of exponents also. Let me see here. This is one you guys should know as well. Okay? if you look these over, you can see the connection between these two. The change of base formula, another one you guys should know. If you want to change the base of a particular log, you just have log of whatever this number is over log of whatever your base is. Alright, and this is where the video cut out, so I'll write down the next bit. There are two ways you can solve a logarithmic equation, and there's a large variety of logarithmic equations out there. Generally, you're going to want to combine everything into a single logarithm. Sometimes, if you have logs on both sides of the equal sign, you'll want one log on one side of the equal sign and one log on the other. Then you want to eliminate the base using the appropriate method. Depending on what kind of equation it is, will determine what method you're going to use. Once you've eliminated the base, then it's just a regular algebra equation. You just solve for whatever variable you're trying to solve for. You can also use your calculator to solve this. When you're given an equation, you can graph both sides of the equal sign as separate expressions in your calculator. And then you just use intersect to find the points of intersection. So depending on the question, you can decide which one you want to use. Sometimes you can't solve a log equation algebraically. Sometimes the only way you can do it is graphically. And then sometimes, if you want to find the exact answer, especially if the answer is irrational, graphing it won't give you an exact answer. It will only give you an estimate. Okay? Alright, you guys, go ahead and copy down these equations. Depending on what kind of problem you come across, these equations come in handy. Feel free to pause and rewind as needed. And that's all for Unit 5.